Today's lesson is going to be about converting measurements. So the first thing that we have to make sure we remember is our identity property. Now this is something we talked about at the beginning of the year, but as a reminder, the identity property tells us that multiplying a number by 1 doesn't change its value. That is going to be the main way that we convert these measurements, is that we're going to be creating kind of some fractions and multiplying by that, but it's not going to change its value because it's technically 1. So I'll give you a basic example. When we were working with fractions, we would take something like 1/2, and maybe we needed to change the denominator. So we would multiply by something like 4 over 4, 4/4, which equals 1. Technically, 4/4 is 1. But we would multiply by 4/4 and we'd get a fraction like 4/8. And we know that 1/2 and 4/8 are equivalent. So we are going to do that same thing with measurements. But instead of looking at a measure or a multiplication like 4/4, we're going to be multiplying by something like 1 foot over 12 inches. Now this doesn't look like it equals 1, but using our conversion notes over here, we know that 1 foot equals 12 inches. So what we're saying is that our numerator of 1 foot and our denominator of 12 inches are equal to each other. And if our numerator and denominator are equal, just like they were when we were multiplying by 4/4, then this conversion, this 1 foot over 12 inches equals 1, just as 4 over 4 equals 1. So that's the idea or the property we are going to be using to convert our measurements. So I did give you the notes over here to the right. I will be kind of breaking them down as we go so that you have the provided conversions. Okay, one of the main things you need to remember as you're making conversions is that diagonal cancels. And that's going to make sense in a moment, but we have to make sure to remember, diagonal cancels. So, as I'm solving these problems, I'm going to set them up kind of using our ratio form, our fraction form, not quite a proportion, but similar. So, I'm going to take problem number 1, which is asking 3.5 feet equals how many inches? So, I'm going to start by taking my 3.5 feet, and you can shorten it, and I'm going to put it over 1. And basically that 1's a placeholder to just kind of get me everything lined up the way it should. Then I'm going to go over to my conversion notes over here, and I'm going to find the conversion of feet to inches. Just so happens to be this very first one here. So we currently know that the measurement is 3.5 feet, but we don't want to know it in feet, we want to know it in inches. Put an equal sign to mean to do that. I'm actually going to put a multiplication sign because remember we're using our identity property and we're going to multiply by 1. So, what are we going to multiply by? Well, we don't want it to be in feet, we want it to be in inches. Since feet is on the top in our first one, we're actually going to put it on the bottom of this second one because diagonal cancels. And we want to cancel out the feet and get it into inches. So feet's going to go on the bottom, inches is going to go on the top. Then I'm going to look at my conversion here, and I know that 1 foot equals 12 inches. So 1 goes with the foot, 1 foot equals 12 inches, so 12 is on top. So again, through that process, the labels is what determined what goes where because diagonal cancels. We want to cancel feet, so we put 1 on top, 1 on bottom. And then we take the conversion of 1 foot equals 12 inches and make sure that the 1 is with the feet and the 12 is with the inches. And the last thing to do is just to multiply this out. So 3.5 feet times 12 inches equals 40 inches. And 3.5 feet equals 40 inches for our final answer. Let's try it again on the next problem. Now this problem I used the same labels, but I switched them around. So this time we have that 63 inches equals how many feet? So let's start and just kind of write it as is to begin with, 63 inches. I'm going to put that over 1, just helps me line everything up. I'm going to multiply that by my conversion. And again, my conversion is always going to equal 1. So who thinks they know what's going to go on the bottom of this conversion? All right, hopefully you said inches because we want to cancel out the inches. We don't want inches anymore. We want it in feet. So I'm going to put inches on the bottom. And then using that same conversion as last time, 1 foot equals 12 inches. That means I have 1 foot on top and I have 12 inches on the bottom. Now this time, when I go to multiply, because now that it's in this fraction form, if you remember about fractions, is we cross cancel if we can, which we can't, and then we multiply our numerators, we multiply our denominators. So I get 63 times 1 is 63, and I get 1 times 12, which is 12. And then because our labels cancel, those inches cancel out, we have a label of feet. Now is 63/12 a very good answer to give? Absolutely not. We need to actually divide 63 divided by 12. So if I take my calculator and I type in 63 divided by 12, I get 5 and 25 hundredths, and make sure I keep my label, feet. So recap for that problem, I put my inches diagonal to each other. I used that conversion, making sure that the 12 was with the inches and the 1 was with the foot. And then we multiplied straight across, got 63/12, not a good answer. So we just divided, numerator divided by denominator, for a final answer of 5 and 25 hundredths feet. Next question. This time we have different labels. We have 336 ounces equals how many pounds? So we're going to start off 336, and put OZ for ounces, over 1, equal, I always do that. Put it equals. Don't do that. Put multiply. Multiplied by our next conversion. And this is, again, we're multiplying by 1. So let's go find the conversion of ounces to pounds. We will find that 1 pound equals 16 ounces. So what label do I want to put, let's say, on the bottom to cancel out? We want to cancel out our ounces. So I'm going to take those 16 ounces and put them down here on the bottom, right from this conversion up here. And then 1 pound, and the shorthand for pound is LBS. Okay, so 1 pound. When I go to multiply this out, I end up with 336 over 16. The ounces cancel out, so my label is going to be pounds. But I need to actually divide this. So if I type in my calculator 336 divided by 16, I get 21, take my label, pounds. That's my answer. These next two problems are exactly like the last ones we did. I'm just giving you metric conversions instead of customary conversions. So I'd like you to try to pause the video and answer these, and let's see how you do. I'm going to begin solving them now. So I would take my 6 and 25 hundredths meters, and I'm going to put it over 1. I want to multiply that by my conversion. Okay, for this conversion, I'm going to put meters on the bottom so that I can cancel out the meters. I would have centimeters on top, and I find that conversion right here. I know that 1 meter, 1 going on the bottom, is equal to 100 centimeters, centimeters being on top. So when I go to multiply this out, 6 and 25 hundredths times 100 equals 625, and my only label left over is centimeters. So 625 centimeters for problem number 1. For problem number 2, I'm going to set it up as 3,525 milliliters over 1 times, okay, milliliters to liters, and that conversion is right here. So I'm going to put my milliliters on the bottom because I want to cancel those out, and I actually cross them out each time. I just find that's very helpful. And since milliliters is on the bottom, that means 1,000 right here is on the bottom, and 1 liter is on top. So when I multiply this out, I would get 3,525 on top and 1,000 on the bottom. And again, that's just multiplying straight across. I don't want to leave my answer like this though, so I'm going to go type it in my calculator. And 3,525 divided by 1,000 equals 3 and 525 thousandths. And again, my milliliters canceled off, so my only label left over is liters. For our last two problems, we are actually going to convert some rates instead of just converting measurements. So for our first problem here, we have that 68 miles per hour equals how many kilometers per hour? Now there's not a big change in this, but it's just a little bit of keeping track of our information. So if I was starting this problem off, I would actually start, I'm going to scoot this down so I have a little bit more room. I would start by putting 68 miles on top per 1 hour. So far the only changes is I have this new label here. Instead of just having a 1 underneath, I need to make sure I keep that the miles per, right here, per hour. And then I'm going to multiply that by my converting factor. And again, that's going to be equal to 1 somehow. And I want to get to kilometers per hour. So the hour is going to stay the same, but it's going to be this mile and kilometer that's going to change. Okay. So I don't want miles anymore, which means I need to cancel miles out. And again, diagonal always cancels out. I'm going to come up to my conversions here, and I'm looking for miles to kilometers. Now, what you will notice is that, or hopefully, or maybe notice, is that we actually have two conversions for this. I have 1 mile equals, and that squiggly equal line means approximately 1 and 61/100 kilometers, and then I have 1 kilometer equals approximately 62/100 miles. So you can use either of these converting factors. Both of them work. The approximately means you might get slightly different answers because what they had to do is they rounded both of these decimals. What I'm always going to recommend, if you have the choice, you want the number 1 on the bottom. And the benefit of that is you won't have to do that extra step of dividing. So since I want the 1 mile on the bottom, I'm going to use this first converting factor here. So I'm going to use 1 mile on the bottom, and I'm going to use 1 and 61/100 kilometers on the top. And again, you easily could have used the other one. You just would have been dividing instead of multiplying, and you'll get a slightly different answer, but nonetheless, it would be correct as long as you used your labels correctly. So when I go to solve this, my last step here is I need to do 68 times 1 and 61/100, and this is absolutely calculator worthy, so I'm going to type that into my calculator, and I get an answer of 109 and 48/100. And again, I would have to multiply 1 times 1, all right, but let's keep track of what labels we have left. We canceled out our miles, but our hours and the kilometers are still there. So what that means is this is 109 and 48/100, and I like to leave my answer in this form, kilometers per 1 hour. And I can leave it just like that, or you could write it out with the word per hour. All right, so recap. We wrote out our initial one just kind of as is. We had to include that label on the bottom. We multiplied by our converting factor, still using that the diagonal is what we want to cancel out. We canceled out our miles, so we had our kilometers on top. I multiplied. Here is my answer. And I actually changed my mind about that last problem. I think I'm going to end it right here. This video got a little bit longer than I thought it would. So that is converting rates. Make sure you use your identity property of kind of finding that converting factor and multiplying by 1. Remember that diagonal cancels, and then really you just have to keep track of those labels as you work through.